Good morning. So we're going to do a little bit of a review first of independence, and then I'll do another video that will have kind of talk about the day. So we're going to share the screen. Okay, so independence. Let's kind of walk our way through what independence is again. We'll go through this two-way table again. We have dominant hand, right or left. We have gender, male or female. What is the probability that a student is right-handed? So we're going to go and find our right-handed students right here. We have the probability of being right-handed is equal to 43 out of 50. Again, it's a complete sentence, probability right. Use that probability notation equals 43 out of 50. We don't simplify it. We don't turn it to a decimal, 43 out of 50. What is the probability that a student is right-handed or left-handed? Well, this is that thing where we're talking about. This is a mutually exclusive thing. If you look at this, this is the mutually exclusive rule. So what that says is the probability of being right or left-handed is dominant. It's the probability of right plus the probability of left. So it's 43 out of 50 plus 7 out of 50, which is going to give us 50 out of 50. Next, the probability of being right-handed and male. So you're a right-handed male, that's the 20 out of the 50. So the probability of being right-handed and male is 20 out of 50. And now this one is the probability of being right-handed or male. And this is that one that we're going to use our formula on, right-handed or male. So it's going to be the probability of being right-handed, which we've figured out already is 43 out of 50, plus the probability of being male, which in this case is going to be 23 out of 50. As you notice, when you add those two up, that gets you 66 out of 50. That's too much. So we have to subtract that overlap because we counted these 20 people twice. The probability of being right-handed and male minus 20 out of 50. So again, that's 66. We're talking 46 out of 50. And again, just so you know, that right there is always going to be considered your work. Now, the probability of being right-handed given you're male. So again, that's saying, I am telling you that you're male. What is the probability of being right-handed? The probability of being right-handed, given that you're male, is we have 23 males, 20 of whom are right-handed. Letter F says the probability of female given you're left-handed. Probability of female given you're left-handed. In other words, in English, how many of my left-handers are female? So in this case, I have 7 left-handed people, 4 of which are female. So that's 4 out of 7. And then the question down here, are the events male and left-handed independent? Okay, the way you check that is you figure out what is the probability of male, and you figure out what is the probability of male given you're left-handed. Because again, the idea of independence is these two if they are in fact independent, these two probabilities should be the same, which basically means adding a condition to the probability doesn't change it. It doesn't matter whether I know you're left-handed or not, the probability remains the same. So again, we have our probability of being male up here is 23 out of 50. Your probability of being male given that you're left-handed, okay, again, that's going to be 3 out of 7. So what we need to do is we need to see are 23/50ths and 3/7 the same. Now I can look at that and say that they're not going to be the same, but we need to get the exact number. So 23 out of 50, you can clearly see is going to be 46%. So the probability of being male is 46%. And then we'll do 3 out of 7, 3 divided by 7.4286. So we'll say the probability of being male given you're left-handed is 0.4286. Since the probability of being male does not equal the probability of being male given that you're left-handed, the events male and left-handed are not independent. Again, the reason you're going to say independent is if they are the same. Basically, if it's saying that if the probability would remain the same. So if this had been 46%, we would have gone ahead and said that being male and left-handed are independent of one another. Basically, doesn't matter whether you're left-handed or right-handed, the probability of being male stays the same. So hopefully that helps. That's going to be what we start class with today.